So thank you very much for sticking it out and not already being on the way to the airport this afternoon. It's our pleasure to be here this afternoon. My name is Elizabeth Staab. I'm the Global Sustainability Packaging Manager at H.B. Fuller. And adhesives, always being a very small component of the final package, of the final good, do play an intricate role of making that product successful, and that's what this innovation is all about.
Thank you, Elizabeth. My name is Charles Smith. I'm co-founder and CEO of a company called Interpac. And we're both here this afternoon to tell you about our journey to develop cold corrugated cardboard. So the goal in this project was to deliver a significant downturn in the CO2 emissions of corrugated board. Corrugated board is something that the packaging industry uses very widely, so it's an important target to hit. So this is all about, did we succeed? So without further delay, let's get started. So the production of corrugated board, it's remained largely unchanged for the last 100 years. The process uses steam, and that's generated by natural gas or possibly by oil. And it then goes on to use electricity to dry out the moisture that the steam put in. And this results in a machine that has a really significant footprint. We're talking over 100 meters long, a machine over 100 meters long, and as you can imagine, that is a big capital investment. 10 million might get you one. So the sheer physical size and the high entry cost results in centralized production. And this in turn means that we have to transport our corrugated board round the country in lorries. And corrugated board is 50% air, so this is not a good thing to be doing. And we have to transport it to where it's actually needed, which is at the sheet converter, the box maker, the guy who prints and die cuts the box. So with a high energy usage, high road miles, I would argue this is not the most sustainable process for the packaging industry to carry on for the next 100 years.
So we've really been looking at, this is an industry standard, corrugated board has been made for the past 150 years, as a matter of fact. And can we really look at this behemoth of an industry standard that is used across many, many applications and really rethink it, reimagine it, reinvent it, and come up with something new, change that process, change the way it is being made, the way it is being handled, in particular with a focus on how can we drive that sustainability footprint and drive down the amount of energy, water, and steam that is used in the process?
And the clear answer is yes, this can be done. We can make corrugated board without using steam. And by removing steam and removing the water from the process, you can shrink the whole machine down to a level of about a third of the size. So a small footprint and low power allows production to be moved to the point of need. So that's at the sheet converter, where it's actually needed and not in a centralized production facility. Interpac has its first production machine already installed, and it's running at a sheet converter plant in Germany. And that enables them to produce their own corrugated board on their own site, rather than having to buy it in and have it delivered by road transport.
So, but we're here to talk about collaboration, and collaboration is not always neat and tidy. You don't come up with the result the first time round. There are roadblocks, there are hurdles, there's different perspectives that need to be overcome in order to come up with this final result that is now in the final phases of fine-tuning. So with those challenges, we were talking about the initial machine development a few days ago. The first time the machine was started, the result was not quite what you had expected, was it, Charles?
No, it certainly wasn't. So our proof of concept machine worked really well, actually, but when we started up our first production machine, I have to say it was pretty much a disaster. It tore the fluting paper into shreds, and it looked very much like we had invented the world's most expensive paper shredder. So it wasn't plain sailing. It has been a journey over 7 years, and to solve the problem, Interpac has collaborated with industry experts throughout to make some core design changes, and that resolved the shredding problem. And then we needed to focus on the quality of the corrugated board we were producing. So clearly we needed to have the same strength as conventional board, but we also wanted to go one better and to remove the two most common bugbears that sheet converters suffer when they buy their board in, and that is warp and washboarding. So warp, it's a common problem. Warped board can severely lead to bad misfeeding through the conversion process. So if you're trying to print on a piece of corrugated board and it's warped, it slows the whole process down and causes big problems. It can also cause an even bigger issue with digital printing, and it can crash into the printing heads and cause damage. So without steam, without water, the Interpac cold corrugator gets round the problem of warped board. The second problem, also very common, is washboarding. That's a rippling effect you can see on the surface of the board, and interferes with print quality. So independent tests have shown that our cold corrugated board has zero washboarding, so it's a super flat surface and provides a high quality print surface, far better than conventional board.
And that's really where the collaboration with H.B. Fuller started, because in order to be able to produce these very flat boards, get that board strength that is necessary, have that immediate paper anchorage so that that inherent strength is there, that's really where dialing in the adhesive technology came to play. So we brought in our R&D and technical experts, sat together with Charles' team. They knocked heads around, ideas around, in order to find that solution, running various trials, testing various parameters, whether that is the humidity around the machine, the humidity in the paper, the residual humidity afterwards. All those very fine factors need to be taken into consideration. And then, of course, this machine, because it has a smaller footprint, does not have a drying tunnel. So then, working with water-based adhesives, we need to make sure that they don't produce wet cardboard, as it were. So really looking at all of those features of the adhesive with solid content, with rheology, et cetera, in order to really fine-tune this process and achieve strong boards, super flat boards at a lower temperature so that the high quality of surface is there for digital print. And once this step was pretty much figured out, then we were looking at the next step of production speeds.
Yes, so together, Fuller and Interpac, we solved the problem of warp, we solved the problem of washboarding by looking at the detailed aspects of the glue, and I think it's fair to say that we thoroughly nailed that aspect, and it's a big improvement on the current state of the art. And we see great opportunities here for digital printing in particular, in developing greater quality print. We then had to move on to the question about commercial speed, vitally important for a large piece of equipment like this, that it is commercially viable and that it returns a profit for those investing into the machine. And again, this came down to collaboration with Fuller to make sure that the glue allowed the machine to run at commercial speeds as an essential part of the glue formula, if you like. Fuller have dialed into the adhesive the right ingredients to give us the productivity we need.
And when we look at sustainability, we focus a lot on the environmental aspects. And of course, those are absolutely key, but it has to make economic sense to make those investments. And that's, again, where production efficiency, making sure that there aren't unexpected line stops, and the overall operating efficiency is as best as possible, because that's when companies, when investments are economically viable, and that also leads to more sustainable solutions. And the result here, in my personal opinion, is absolutely phenomenal in rethinking, reimagining, and really reinventing this process, driving down energy usage by 40%, using essentially no water at all, except for the water in the adhesive, of course, and then reducing transportation, because all of that corrugated board that otherwise would be coming in on a truck is now coming into the sheet converters as a roll of paper instead. And that overall leads to emission savings of 60%, which for a tried and tested technology such as corrugated board, which is really omnipresent in packaging, is really significant and can really turn the dial on the carbon footprint of packaging overall.
That's right. We really have taken this process that's been going on for 100 years and turned it on its head. And I'm very proud of that achievement. And an overall reduction of 60% of carbon emissions per tonne of corrugated board is highly significant. And I don't think I've heard anything in the last 2 days that comes close to that sort of level of reduction in a commonly used product in the packaging industry. So just to give you a little bit of background about some of these figures that we've been talking about here, Interpac commissioned an independent analysis using FEFCO's own data taken from about 470 corrugator installations, so, and that's widely available information. So it's based on some good set of data averages. And I think in summary from my end, I wonder what other innovation can make such an immediate and substantial impact on the sustainability of packaging.
And so coming back to the adhesive, my favorite part about this really is that adhesives are oftentimes neglected and forgotten, treated as a sun-dry expense. But really this example really shows very well that a very small component of the overall final product can make such a crucial difference and mean the success of a new process, of a new invention, and really achieve the result of a higher quality product, a completely new process, driving down carbon footprint by really focusing on those small details of the adhesive that then drives a efficient production process.
So in summary, cold corrugating, for me, the key to this is it moves production to the point of need. That is the essential ingredient that builds upon the CO2 savings. We're moving away from centralized production using steam to create moisture and then using power to take out that moisture. So it's a double hit for conventional corrugators. And removing the steam transforms the whole power picture and delivers a reduction in CO2 that I think both the industry, the packaging industry, and end users will be very pleased to take advantage of.
And so that, in summary, just to show how collaboration, we've been talking about collaboration a lot these last 2 days, is not always smooth sailing. There are always stumbling blocks, and each individual step needs to be looked at very carefully. So we are currently dialing in the final settings on the machine on the adhesive with traditional adhesive technology, and the next step will then be to be converting the adhesive to a product based on renewable raw materials to further draw down the carbon footprint of this product overall. So thank you very much for your attention, and we're happy to take any questions.
Thank you.
Yeah, I would have had plenty of my own. This is actually quite mind-blowing. So saving the best for last in terms of big innovations. I've got one here for you, and the question is, assuming cold corrugation comes with a higher price tag, how willing is the market to pay for it? And are there existing LCAs comparing this one to traditional ways?
Sorry.
You need to go back to the mic.
Yes, so is there a price tag on the machine? Yes, of course there is, if I understand your question correctly. But does it cover that gap between the need for sustainability and the need to actually make a profit?
So I think we need to distinguish here a little bit. So I think one thing is there is an investment cost.
Yes.
And you're saying it's a 2-year return on investment, which in our industry is pretty impressive, right?
Yeah, so on an earlier slide, it was up there, but I didn't go through it all, so it didn't turn into a completely overt sales pitch for Interpac. But the sheet converter should save about 30% on the cost of their board by making it themselves.
And that's the second half of the question. So the question is there, aside from the investment in the daily running of it, is the product more expensive to whoever runs it, and will that reflect in the market prices?
No, so the product, basically what's happening is by making board yourself, you are taking the profits from your supplier and keeping them for yourself. So you're transferring the profits from the sheet feeder, the guy with the big corrugator, and you're taking them as savings as you make your own board. So you should get a return on investment in under 2 years, and the board is cheaper. Now, whether you, as a sheet converter, pass that on to your customer or not, of course, is beyond the...
So essentially, you don't have to go to your customers and ask for more money. However, you might piss off your suppliers.
Sorry.
Yeah.
I mean, summarizing it in a layman's way.
No, but you're basically moving the production sites. And instead of having very large corrugators that are very centralized, you're essentially decentralizing the production of the corrugated board, which of course then makes sense for, or could make more sense for, niche applications where in particular high quality digital print is requested, where you're using paper that has various coatings on it that are particularly heat sensitive, that therefore don't want to be going through its steam process on a traditional corrugator. So really identifying those final applications where you want to be active, being able to diversify, potentially upgrade your portfolio, that's really where some of those very sweet spots are.
Yeah, and you're not going to drive around lots of trucks with air in them.
Precisely.
As a result.
Yeah.
Very good. Very impressive. Thank you very much.
Thank you.
Great.